Okay. Bismillahirrahmanirrahim. Okay, so velocity, we all know that the formula for velocity is distance or displacement divided by time. So whether you take displacement or distance, but I mean, the concept is the same. The only difference is of the direction, meaning that, whatever distance a person has traveled divided by time, right? So if we rearrange this equation, we can also say that the product of velocity and time will give us distance traveled. Is that right?
Yes, miss.
Yes. So if you want to find out the distance traveled, another way of finding out is multiplying velocity with time. Okay. Just excuse me a little. Okay. So when you have this, when you have velocity on the y-axis and time on the x-axis, then when you multiply velocity and time, what are you actually doing? Why is it that distance traveled is equal to the area under this velocity time graph? Why is that? Because if, for example, you consider this a rectangle, OABC, how do you calculate the area of a rectangle? The area of a rectangle is length multiplied by breadth. Everybody knows that, right? Area of a rectangle is length multiplied by breadth, right? Now, our rectangle, in this case, our rectangle is this graph, velocity time graph. This is our rectangle, okay, where the breadth is the velocity and the length is the time. Okay, so length is time and breadth is velocity, which is the same as this, doesn't matter. Okay, so that is why the product of that is why the area under the graph is equal to the distance traveled by the object. Okay, so the distance traveled can be calculated by multiplying velocity and time, and also the area under the graph. Now, in this particular location, in this particular graph, tell me what is the velocity and what is the acceleration? Yes. What is the velocity and what is the acceleration? Yes, Zainab?
Velocity is 20 meters per second, and
Okay.
over here it's a straight line. So it's telling that the velocity is constant. And when velocity is constant, that means there's no acceleration.
Yes, and so zero acceleration. No acceleration because the velocity is not changing. What was acceleration? Real quick recap. What is acceleration?
Acceleration is when the velocity of an object changes.
Elise, can you please define acceleration?
Acceleration is the rate of change of velocity.
Right, the rate of change of velocity. And we can see that velocity is not changing here at all. It is 20 meters per second throughout 5 seconds. So that means acceleration, there is no change in velocity, and therefore there is no acceleration. Okay, now we know that the area under the graph is equal to the distance traveled. But remember, not all the graphs, not all the graphs will have the area under them equal to distance traveled. For the area under the graph to be equal to the distance traveled, remember the graph should be of velocity against time. Okay, well, you can have it, I mean, the graph can be turned the other way around with time as the y-axis and velocity as the x-axis. Like, for example, if you have a graph this way, sometimes to confuse you, they do this. They turn the graph the other way around. So they might have time on the y-axis and velocity on the x-axis. If they give a graph this way and then ask you to calculate the distance traveled, the area which is under the graph, will still be equal to the distance traveled. Why? Because you are multiplying the same thing, same two things, doesn't matter whether you have velocity here as y-axis or x-axis. As long as the graphs are between velocity and time, the area under the graph would be equal to the distance traveled. Okay, but if you have anything other than velocity, for example, if you have distance here instead of velocity, if you have graph between distance and time, okay, so if you now calculate the area under this graph, so what are you basically doing? You are multiplying distance and time. You are multiplying distance and time. And what do you get when you multiply distance and time? Do you get anything? No, you don't get anything. Okay. So we don't have any quantity which is the product of distance and time. So therefore, the area under this particular graph will not give us. Okay, by the way, distance traveled is already there and the y-axis. So we don't calculate the area under the graph when you have a graph of distance against time. Okay. Okay. Now this area under the graph being equal to distance traveled is true whether the acceleration is uniform or if the acceleration is not uniform or if it is changing. In both the cases, still the area under the graph is equal to the distance traveled. Okay. Now in this particular case, what is the acceleration? In this graph, can anybody tell me what the acceleration is? Who is this unknown? Who is this unknown? Yes, Abdul Wadood?
Acceleration is 20.
Acceleration is 20, yes. So how did you find that out?
Ma'am, because the constant velocity, at 20 that was constant, and after 20 it started to increase till 40.
Yes, so see, acceleration is the rate of change of velocity. So how is the velocity changing? The velocity is changing, okay, another thing I want to mention here is what is the gradient? How do you calculate the gradient? We calculate the gradient by dividing the y-axis by the x-axis, by dividing the y-axis or the x-axis. For example, if I want to find out the gradient here, how can I do that? So let's say I'll take this point and I'll take this point. Okay, what are the coordinates here? X is 0 and y is 20. So I'll mark it as x1 and y1. Here x is 5 and y is 40. Okay, so this is x2, y2. And so gradient would be, okay, let me do it on the paper because I know you cannot see. Okay, so gradient would be y2 minus y1. Have you guys done this in math? How to calculate the gradient?
Not
Yes,
yet.
miss.
And we
Yes,
have
miss, I
done
did.
this in physics. In physics.
No, but have you
Miss,
done?
isn't
Also in math I've done.
Yes,
miss?
Have you done these graphs and calculation of gradients in math?
yes.
Yes, sir.
Yes.
Yes, miss.
Okay, then good. Okay, so now,
Miss,
yes.
isn't the gradient supposed to be the area under the graph?
Yeah, see, I had this doubt in my mind that maybe you guys don't know this difference. No, beta, and I will tell you, they are exactly opposite. See, distance, okay, let me finish this and then I'll come to that point. So this is how we calculate gradient, right? Y2 minus y1. So my y2 is 40, y2 is 40 and y1 is 20. Okay, here. So y2 minus y1. And then x2 is 5 and x1 is 0. Okay, so, oh, sorry, you cannot see. So 40 minus 20 is 20, and 5 minus 0 is 5. So 5 ones are 5, 5 fours are 20. And so 4, okay, 4. Now what should be the unit? What should be the unit? So this was meters per second, and this was second, right? This was meters per second, this was velocity, and this was time, right? So meters per second divided by time, right? So that means this becomes meters per second square. So the units should be 4 meters per second square. That means this is gradient is acceleration. Gradient here is acceleration. Now I'll tell you the difference between gradient and the area area under the graph. Area under the graph. Okay, the gradient you find by dividing the y-axis by the x-axis. Gradient you find out by dividing the difference in y-axis by dividing the difference in y-axis by the difference in x-axis. See, y2 minus y1 is the difference in y-axis divided by the difference in x-axis, x2 minus x1. Okay, so, or in simple words, we can just say dividing y by x. Okay, that is how you calculate gradient. How do you calculate the area under the graph? By multiplying y and x. Okay, how do you get the area under the graph? By multiplying y and x, you get area under the graph. Because remember, look at the graph as a polygon. Okay, it can be a rectangle, it can be rectangle and triangle, okay, or it can be any other shape. Like for example, this. Now this is not a polygon. Okay, this is, so here you will not be able to use any formula, but then you will have to count squares maybe which are inside, or you'll have to you know, use some other method, because this is not a straight line, or maybe you'll have to just estimate. Okay, so this is the difference. In gradient, you divide y-axis by x-axis, whereas in area under the graph, you multiply y and x. Area under the graph, you have to multiply length by breadth. Okay, length by breadth. So you are multiplying y-axis and x-axis. Whereas in gradient, you divide. Okay, gradient is basically, you know, finding out how is the y-axis increasing with respect to x-axis. Did you understand? Like for each unit increase in x-axis, how is the y-axis increasing? Or let's suppose for 1 unit increase in x-axis, how many units did y-axis increase? That is the gradient. Did you understand? Did you guys understand? Sarah?
Yes, miss. Yes, miss.
Yes, so please don't be confused. So remember, gradient is different from area under the graph. Okay. Okay, so what do you think is the gradient here? What is the gradient here? Tell me, what's the gradient?
0, 0.
Very good. And what is it called? I mean, what quantity is it? So you
Uniform.
no, beta. What my question is, like, you know, y-axis is velocity, x-axis is time. When you divide velocity by time, what do you get?
Distance.
No, when
No.
when you divide velocity by time, what do you get? It is the rate of change of velocity is what?
Acceleration.
Yes, acceleration. Yes. So the gradient of velocity time graph is acceleration, whereas the area under the graph is the distance traveled. So gradient would be acceleration, whereas the distance under the graph will be, sorry, the area under the graph would be the distance traveled. Did you understand, Sarah?
Yes, miss.
And others, is there any confusion?
No, miss.
Yes, yes, Moaz, you want to ask? Something?
No, miss.
Okay. So I calculated the gradient and it came out to be 4 meters per second square for this graph. So that means the acceleration is 4 meters per second square, meaning that for in each second, the velocity is increasing by 4 meters. But the velocity is increasing by 4 meters per second. For each second, the velocity is increasing by 4 meters per second. That's what it means. Uniform acceleration, meaning that the velocity is increasing at a steady rate. Okay. Now we have this non-uniform acceleration. Now, what's happening to the acceleration here? Can I have a ruler? Ruler, small ruler. Oh, yes, yes. Thank you. I got it. Okay, what's happening to the acceleration here? Yes, Zainab?
It is increasing but non-uniformly.
Increasing? It's increasing?
No, it's decreasing. It's decreasing non-uniformly.
Okay, and how did you say that it's decreasing?
Because first it's like over here, first it's increasing a bit, but then the speed isn't, there's not much difference in the speed, so then it's kind of same. So then it's like you can tell that it's decelerating now. Like there
Oh,
isn't much difference in speed.
so how can you tell?
Like if the graph is steep, then that means it's like either accelerating or decelerating. But if it's kind of becoming a straight line, or it's like processing to be a straight line, that means that it's slowing down, or there isn't much difference in speed.
Okay, if I ask or if you are asked that what is the acceleration of the object at this point, how will you calculate that? If anybody asks you, if a question asks you what is the acceleration at this point, how will we calculate? Any idea?
V2 minus V1 over time.
V1 minus V2 divided by
V2,
time. Yeah,
yeah, V2,
so what will be your V2 and what will be your V1?
V1 will be 0, 0, and 0, and then V2 will be 20.
Okay, your thinking is good, but look at this. See, this is not a straight line, okay? This is a part of a circle. Consider this because it's a curve, so we will consider it as part of a circle. Okay, if you have a curve and if they ask you to find acceleration at a particular point, how do we calculate it? We draw a tangent. You know what a tangent is?
Yes, a tangent
Yes,
line.
Yes, Rafe, please tell us what is a tangent?
Teacher, is a tangent is a line that we draw over the curved graph to find out its gradient.
No, beta, that's not the definition of a tangent. We do draw a tangent to find the gradient, but that's not the definition. Tangent is a line that touches a circle at one point and is perpendicular to its radius. Okay, and it should be perpendicular. For example, if this is a part of a circle, let's suppose, so radius would be something like this, and it would be perpendicular to this tangent that I have drawn. So remember the definition of tangent. This, by the way, is math. Maybe you have done it in math. Tangent is a line that touches a circle at a point and is perpendicular to the radius of the circle. That's a tangent. Okay, so if we want to know the acceleration at this particular point, let me call this point T, for example, then I will have to draw a tangent. The reason why tangent is important, like, I mean, I can make a line this way as well, right? But it has to be perpendicular to its radius. Okay, so just roughly get an idea, imagine a circle and roughly get an idea where will its radius be pointing, and then right angles to it at 90 degrees to it, your tangent should be there. Okay, now once you have this, now it's easy for you to have your v2 minus v1 divided by t2 minus t1, which is the same thing as gradient is equal to y2 minus y1 over x2 minus x1, only that y2 and y1 are v2 and v1, x1 x2 and x1 are t2 and t1. I hope you're getting what I'm saying. If not, then I can write it this way: v2 minus v1 over t2 minus t1. So it's the same thing. So this is acceleration. So gradient in this case, in velocity time graph, so gradient is equal to acceleration. Okay. Okay. So now v2 would be 20. V2 would be 20. But then v1 would be what? V1 cannot be 0.
It will be 10.
Yes, it can be 10. Can it be 10? Yes, it can be 10. So any point on this line, and because 10 is on this line, so yes, 10 can be V1. Very good, Sarah. So V2 minus V1, and then what will be T2? T2 would be this 1, and T1 can be 0. So you can have 20 minus 10 over 1 minus 0. And so you will have 10 meters per second square will be the acceleration at this point. Okay, so did you understand how to calculate the acceleration? Now, if you have understood this, now look at what's happening to the gradient as we progress along the graph. At this particular instant, the tangent is this way. This is the tangent. Okay, at this particular point. At this particular point, the tangent is this. Can you see how steep it is? So the acceleration,
Yes.
yeah, so the acceleration is quite big, okay, quite large. At this point, the tangent would be almost this. So can you see now the acceleration has decreased? Now this is less steep as compared to this. This is less steep as compared to, so what's happening to the acceleration? It's decreasing. Here, look at this. Now this is so gentle. Yeah, it is so gentle. So as you move this way, the acceleration is increasing. As you go forward, the acceleration is decreasing. Okay, so much so that eventually it is flat. Eventually it's flat. What does that mean? That now the acceleration is
0.
0. Why? Because the velocity is now flattened. It has flattened off, meaning velocity is no longer changing. And when the velocity stops changing, acceleration is 0. So you can see that how from such a big value, it is decreasing so much so that it is eventually 0. So that's why we are saying acceleration is decreasing. Okay, we cannot use the word deceleration here. Okay, Zainab, you use the word deceleration. No, we cannot. Now, deceleration, when can you say that deceleration is going on? When you see the graph coming down, meaning when the velocity starts decreasing. Now the velocity has, the rate of change of velocity is decreasing, but velocity itself is not decreasing. It's still increasing. Okay, it's still increasing. Its rate of increase has decreased. यानी कि आहिस्ता आहिस्ता इंक्रीज हो रही है, लेकिन हो रही है, इंक्रीज ही हो रही है, डिक्रीज नहीं हो रही. Okay, now when it will start decreasing, that's when you bring in the term deceleration. Do you understand that?
Yes.
Yeah, did you understand that? Okay, so okay, velocity and time. Okay, now they have given a few notes here and they are worth noting. Please take care of the fact that the unit of time is the same on both the axes. If you have seconds, then velocity should be meters per second. If you have hours here, then velocity should also be in, you know, kilometers per hour. And so yeah, you know, units should be, so you should take care of the units. Okay, it's true. Okay, this rule for finding distances traveled is true even if the acceleration is not uniform. Yeah, we have already discussed that. So whether the acceleration is 0 or uniform or non-uniform, in all the cases, area under the graph will be equal to the distance traveled. Okay, then let's move on to, yes,
Miss,
Zainab? Yes.
Miss, how do we find the area under the your non-uniform time velocity time graph?
Yeah, I just mentioned that you will be asked to either estimate, just make a rough guess, or you count the squares. If they give you a squared graph, then you'll have to count the squares, but there will be some way that they'll give you. Okay, or they will just ask you to estimate. If you have options, you choose the best option. For example, if somebody asks me how, to calculate the distance traveled under this graph, you know how I would do? So roughly, if I, I will estimate, and the way I will estimate is that, first I will consider this as a rectangle. Okay, let's call this A. So OAXY. I will multiply the length by breadth. So this is 30 and this is 5. 5 into 30 is 150, right? So I should get, and this is more than half, right? This is more than half. So half of 150 is, what is half of 150? 2 sevens of 14, and then
75.
75. So something more than 75 and less than 150. My answer. So I will look at the options. If it's an MCQ, I will look at the option. So the option which is between these two numbers should be greater than 75 and less than 150. Okay, because it's greater than half. It's more than half of this rectangle. So this is how you estimate. Okay, you will make your best estimate. Or if they have given you squared graphs, then you count the graphs. And then you have shortcuts of counting graphs, right? Okay. If we come across a question like that, then, this thing will get clearer. Okay.
Miss.
Okay, now where you have this graph distance against time. Now tell me, what would be the gradient here? What would be the gradient here? So gradient is y-axis divided by the x-axis. The y-axis in this case is distance, right? And x-axis is time. So what do you get when you divide distance by time? Distance divided by time is equal to what? Yes.
Speed.
Yes. Velocity or speed. Yes. So the gradient would be velocity. Okay. So if in any situation you are not sure what the gradient is, just divide the y-axis by x-axis and see what are you getting, what quantity are you getting. If you have velocity here and time here, the gradient is acceleration. But if you have distance in the y-axis and time in the x-axis, so distance divided by time is velocity. So that means the gradient must be velocity. Did you understand? Okay, what would be the distance what would be the area under this graph? Now here the y-axis is distance, it's not velocity. So now the area under the graph would be nothing. We don't have any quantity. We don't calculate the area under distance time graph. We don't calculate the area under the distance time graph. Okay. Okay, what's happening here in this graph? What's happening here? Can anybody explain this? So what's happening to the gradient? Okay, tell me. What's happening to the gradient? I'll give you hints. It's okay.
It's increasing.
Very good. What? How?
Because first it's a straight line from the start, but then it's going up,
Yes. So again,
slanting.
Teacher, it's accelerating.
yes. So yes, very good. So we will look at the tangent. Okay, what's happening to the tangent? Here, the tangent is this way, then this way, and can you see it's getting steeper? It's
Yes.
getting steeper, it's getting steeper, and here it's almost vertical. Okay, so what's happening? It's getting steeper. That means the gradient is increasing, and gradient is velocity. So that means velocity is increasing. And when velocity is increasing, you have acceleration. So is the acceleration uniform here? Is the
No, ma'am.
No,
No.
no. Uniform acceleration meaning constant acceleration, meaning the acceleration is constant. So because the velocity, because the velocity is increasing, so there is acceleration. Okay. If you had a straight line, if you have distance times straight line, what's happening to acceleration here in this graph? What's the acceleration here?
Teacher, it's constant velocity.
It's constant.
What is constant, beta? Velocity or acceleration?
Velocity.
Very good. If velocity is constant, what about acceleration?
That is also constant because
Yes,
the
ma'am.
velocity is constant.
Who will tell me what's
Ma'am,
happening?
acceleration is not constant.
What is it then?
Ma'am, its acceleration is increasing.
बेटा अच्छा एक मुझे बात बताओ. What?
Yes,
Yes.
but isn't it that when the velocity changes, then the acceleration is changing? Since the velocity is not changing, then the acceleration will also not change.
Yeah, right. So velocity is not changing. Velocity is constant. That means
The acceleration is also constant.
Zero.
So
very good.
acceleration is
Who
zero.
said zero? Who
Teacher, I
said
said
zero?
zero acceleration.
Yeah, who said zero? Yes,
I said
acceleration is zero here. Yes, you know why? Look at this formula. Acceleration is what? Change of velocity divided by time, right? Change of velocity is, there is no change of velocity.
yeah. It's
Velocity is
constant
constant.
velocity, no
So
change.
that means this is zero. If this is zero, acceleration is zero. Velocity is there. Velocity itself is not zero. Please don't confuse. Velocity is constant, it is uniform, but it is of some value. I mean, it has some value. Let's say, okay, what is the velocity here? 10 divided by 1 is 10, 20 divided by 2 is 10, 30 divided by 3 is 10, 40 divided by 4 is 10. So that means the velocity is 10. Velocity is 10 throughout. Okay, the velocity is constant, it is 10, but it is not changing. Change of velocity is acceleration. So because it is not changing, acceleration is zero.
Zero.
Yes, acceleration is zero in this case. Okay. Now, yes, this is a little confusing, but when you see a graph of velocity or distance against time, ask yourself a few questions. Like, for example, what is the gradient? How will you find out the gradient? Divide the y-axis by the x-axis. What am I getting? Distance divided by time is velocity. Is velocity. So that means gradient is velocity. And if you have velocity against time, this sort of graph, then what is the gradient? What do I get when I divide velocity by time? I get acceleration. So in this case, gradient is acceleration. Okay. Now distance, what is the area under the graph? What do I get when I multiply velocity and time? I get distance traveled. So that means area under the graph is distance. Now here, what do I get? What is the area? If you are getting confused, then just ask yourself, if I have to calculate the area under the graph, but first let me see, what do I get when I multiply distance by time? No, I don't get anything. So that means I don't have to calculate the area under the graph. Okay, distance multiplied by time, I don't get anything. Okay, so these are the questions you should ask yourself so that you don't get confused. Is there any confusion so far?
No, miss.
No, miss.
Okay, now they have also explained how to calculate the velocity at this point, t. What did they do? They drew a tangent. Oh, yeah. They drew a tangent. Can you see? If you have the book, if you take out the book, if my camera is not clear.
Yes.
Teacher, what is the page number?
Page number is 14. 14. 1-4. Look at this. See how they have made a tangent. Have they made a tangent? Right?
Yes, miss.
Yes. Okay. Now, y2 minus y1. What is y2? 4D. Okay. Y1, 0. Okay. Now, x2, 4. X1, 2. Okay. Now, if you calculate it, I have done this calculation here. I don't know if you can see this, but let me do it here. Okay, so that's how they have calculated the velocity at point D, and basically they are calculating gradient, but in this case gradient is velocity. Okay, so y2 minus y1 divided by x2 minus x1. So y2 is 40. Is everybody convinced? Why is y2 40?
Yes.
Yes.
Because
Yes.
we will use this tangent to find out the gradient at this particular point. Y2 is 40. Okay, y1 I will take as x2 is 4 and x1 is 2. So 40 divided by 2, which will give me 20 meters per second. And now the unit will be meters per second because the gradient is velocity, not acceleration. Yeah. Okay. Okay. Is this confusing? Tell me frankly. It's okay. Do you find this confusing?
A little bit. There are some
At first it
concepts
was,
which are
but
like, which if you think too much, they get confusing.
Yeah, and then they will try their best to confuse you. Yeah. Okay, now these equations, there are 4 equations of motion. Do you want to do them? Has your teacher done them with you?
yes, ma'am.
She taught us, miss, what were the equations, but not how the equations were formed. That's not included.
Sorry, can you please repeat?
Like there are 4 equations. She taught us like how we're supposed to use them, but it's not included it's not included to explain how those equations were formed.
Oh, the derivation is not included, but their application is?
Yes.
Well, by the way, these yellow parts of the book, see, this is yellow part, right? If you look at the preface of the book, areas highlighted in yellow contain material that is not part of the Cambridge IGCSE syllabus. It is extension work and will not be examined. Okay, and this is the yellow part. Okay, so if you want, I mean, the end of chapter questions don't have their application as well. Okay, and they are only explaining their derivation. Their derivation, by the way, is very interesting. If you are interested, we can do them. But if you want me to do the end of chapter questions instead, then we'll just jump off onto the end of chapter questions. It's totally up to you. What do you
Teacher,
want?
end of chapter questions.
Okay, yeah, I agree with you. We don't have time. Okay. Question number 1. Okay, have you guys done these questions with the teacher?
Yes, we did last year.
Last year,
Yeah.
grade 7?
No, I'm from grade 9. So it's like last year.
Oh, okay. So can you explain us? Can you explain question number 1?
They're asking about the graph. So how far did she travel? We have to take in the A part, we have to take the whole distance that she traveled.
Okay, the distance time graph for a girl on a cycle ride is shown in figure 3.5. How far did she travel? So that's easy. Now, first look at the graph. You have distance on the y-axis and then you have time on the x-axis. Can you see these answers written with pencil?
No, miss.
No,
No,
ma'am,
it's
they're so light.
blur.
They're
They're
so
blur.
light.
Okay, good. So, so how much is the distance? What is the total distance that the girl has traveled? That's easy.
60 meters.
60.
60
Yeah,
meters.
60
okay.
meter.
60 and the unit, don't forget the unit, kilometers.
60 meter.
Okay. Then how long did she take?
6 hours.
Are you sure?
Yes.
Okay. 1 hour between 1 and 2 p.m. 2 hours between 2 and 3. 3 hours. 4 hours. 5 hours.
Sorry, 5 hours.
Yeah. 6 minus 1. Okay. If this was starting from 0, then you could have taken, but since it's not starting from 0, it's starting from 1, so 5 hours. Okay. Next part. What was her average speed in kilometers per hour? And how do we calculate the average speed? What were 2 ways of calculating average speed that I taught? 2 ways of calculating average speed.
Distance divided by time.
Yes, that is one. Okay, distance divided by time. And the other one was that if you have more than one speed, add them up and take their average. Okay, that's the other way. So, but here we have the total distance traveled and we have the total time taken. So that's easy. 60 divided by, so the units will be kilometers per hour. So 60 divided by 5. So, and it would be, speed would be, average speed is distance is 60 kilometers divided by 5 hours. And so 5 to the, right? Am I right? Yes. So 12 kilometers per hour. Yes. How many stops did she make? How many stops did she make?
2.
2.
Okay, how do you know?
Because of the straight lines.
Because she took.
Okay, what?
Because between BC and DE there was no distance traveled more, and they're constant. So it means she stayed.
Yes, exactly. That means in BC, there is no increase in distance, but time is passing. That means she stopped over somewhere. Again, here the distance is not being covered, but the time is passing. So that means she stopped somewhere. Okay. How long did she stop for altogether? Okay. So for
1
this,
hour.
okay. So for this, first of all, we have to know what the smallest box or division stand for. These are the squares. I'm darkening them in case you cannot see. So now these are the small boxes. Now, what time period is being represented by the smallest box? So 2 p.m. is exactly here. Okay. So this is small boxes, half an hour. Small boxes, half an hour. Can you see this? 2 boxes together give me 1 hour. 2 boxes together give me 1 hour. 2 boxes together. Can you see? Yes. So one small box is half an hour. Okay. So B and C is 1 box. Can you see? B and C is
1.5.
So this is half. This is 1.
1.5.
Yeah. So did you see
1
how
1 hour and 30 minutes.
1.5 hours? So did you see how I calculated? See, right now you should be interested in the method, in the working, rather than the final answer. You should learn how to get to the final answer. What are the tips and tricks? So you have to find out what the smallest division stands for, and then it will be easier for you to calculate the time. Okay, let's move on. What was her average speed excluding the stops? So how will you exclude the stops? So again, average speed is the same formula, distance traveled divided by time, right? Distance traveled divided by time. But this time we will exclude the time that she spent while she was not traveling. That was 1.5 hours. Remember, that was
So we're gonna minus it.
right. So we are going to subtract 1.5 from 5. Total time taken was 5 hours, right? Total time taken was 5 hours. 1.5 hour she spent during her stops. So 5 minus 1.5 is what? 4 minus 1 is 3.
4.5.
3.5. Okay, 3.5. So the distance traveled is going to stay the same, which is 60 kilometers, but the time would be 3.5. So now divide and tell me. One's a 5, two's a 10, 0, 120 divided by 7. What is that? Come on, use your calculators. Come on, somebody, do it for me.
17.14.
Yes, ma'am. 17.14.
Yes, 17.14. So is that the answer?
Yes.
Is that the answer at the back? Can somebody check for me? Okay. For G, how can you tell from the shape of the graph when she traveled fastest? Over which stage did this happen? Like which part of during which part of the graph was she fastest? Now, fastest means that they want you to look at the velocity, right? And velocity is going to be the gradient, because remember, this is a graph of distance against time. The gradient is going to be the velocity. Okay, so gradient means how steep this graph is. How steep is the graph? So where is the graph steepest? Is this steep, or this, or this, or this? Which one is the steepest? Which
E
part is
to
this?
F.
Yes.
E to F.
Yes, E to F. You
E
don't
to
even
F.
have to, you don't even have to calculate. Just by looking, you can tell that EF is the steepest part and therefore the fastest. Okay, so you can just simply say it will depend upon how many numbers they have given to this question. If it has like more numbers, then maybe they want you to calculate. And if it has only one mark, then just say that because the graph is the steepest between E and F, therefore velocity is the greatest. Okay. Okay, now question number 2. The graph in figure 3.6 represents the distance traveled by a car plotted against time. How far has the car traveled at the end of 5 seconds? So again, this is a graph of distance against time. So what is the total distance traveled? Easy.
100.
100 kilometers, right? What is the speed of the car during the first 5 seconds? Okay, speed is going to be what? The area under the graph?
Distance divided by time.
That is gradient, right? say beta, okay, say that this is going to be the gradient, okay? Distance divided by time gradient. So what is the gradient? Can anybody calculate it for me?
20.
How did you get? Come on. बेटा कुछ कुछ तो आप भी करो ना, सारे मैं आपको करके दूं.
The answer is 20 kilometers per.
Yeah, I know the answer. I want to know how. How did you
Distance divided by time. 100 divided by 5.
Right. So gradient, again, I would do it this way. Gradient, which is the velocity, is equal to y2 minus y1 over x2 minus x1, or you can say v2 minus v1 over t2 minus t1. v2 is 100 minus 0 and t2 is 5 minus 0. So 100 divided by 5 is 20 meters per second. Okay, okay. Part C. What has happened to the car after A? What happened to the car after A? And so whatever your answer is, please also tell me the reason.
Teacher, it starts to decelerate.
Okay, how?
Because the graph is curving.
Okay, is it curving upwards?
Sir, it's curving downwards.
Okay, so that means the velocity is
Decreasing.
decreasing, right? So when it is decreasing, that means deceleration. So that means slowing down. That's absolutely right. Okay. Part D, draw a graph showing the speed of the car plotted against time during the first 5 seconds. So now if you are asked to plot a graph of velocity against time of the same car, so I'll keep this graph here. Now we will plot a graph of velocity against time. What should it look like?
It will be a straight line.
Okay. 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So it will be a straight line. Okay, let's see. This is 5. This is 10. 15. This is 20. This is meters per second. Okay, so it was the 520. Okay, so 20 was the velocity. So till 5 seconds.
Till 5, it would be a straight line.
Right.
Which shows it's constant.
Okay, and then what happens after that? Okay, have they asked you? Okay, so they have asked you to draw a graph showing the speed of the car plotted against time during the first 5 seconds. So yeah, this is fine. But after 5 seconds, it decreases. How much we don't know, but it decreases. Okay, but we don't know how much. Okay, then question number 3, figure 3.7. So I'm really quick. I am trying to. Do you guys have confusion in these questions, or you can do them?
Miss, we can do them.
You can do them? Okay,
Yeah.
then, okay, then do these with me. Figure 3.7 shows an incomplete velocity time graph for a boy running a distance of 100 meters. What is his acceleration during the first 4 seconds?
V2 minus V1 over time. So
It
that
will
will
be
be 5
It will be
minus
0.
0 over 4. No, it will be 5 minus 0 over 2. So 5 divided by 2, right?
5 divided by 2 or 5 divided by 4? This is 4,
Oh,
right?
5 divided by 4, yeah.
Yeah, for the first 4 seconds. Okay, yes, Maruj, she's right. Sarah is correct. Velocity, sorry, acceleration. They did not ask you to calculate. Okay, wait. Yeah, so acceleration is not 0. Velocity is changing. Okay, velocity is changing. Acceleration will be 0 when this is a straight. Like here, the acceleration is 0 because the velocity is not changing. But here, the velocity is increasing, so there is acceleration, okay? And it is 5 divided by 4. 5 divided by 4, which is 1.25 meters per second square. Okay, how far does the boy travel during the first 4 seconds? So how will you calculate the distance traveled by the boy during the first 4 seconds?
The area under the graph.
Right. And the area under the graph is?
A triangle.
Yeah, this is a
Triangle.
triangle. And how do you calculate the area of a triangle?
1
1/2
by 2
Above
multiplied by
into
1 by
height.
2 multiplied
base.
base multiplied by
Right.
height.
Yes, area of a triangle is half into base into height. Half into base into height. Okay, so base would be 4. In this case, 4. Height would be 5.
5.
Yes. So 2 ones are 2 twos are 4, 2 fives are 10 meters. Okay, and the unit will be meter because the velocity is also given in meters per second. So 10 meter is the distance traveled. Okay, in the next 9 seconds. Now, next 9 seconds, meaning you will add 9 to 4. 9 plus 4 is 13, right? So till 13. 13 is midway between 12 and 14, somewhere here. So we will calculate the area of the rectangle. So now what is the length of this rectangle?
4 minus.
13 minus 4.
Yeah,
13 minus 4, which is 9, right?
9.
Yes. So 9 multiplied by
5.
5. 9 fives are? 9 times 5 is?
45.
45.
So this is 45. Okay. This was 10. So 10 plus 45. Okay.
55.
55.
Right. So total distance at the end of 13 seconds is 55. Okay. Copy and complete the graph showing clearly at what time he has covered the distance of 100 meters. Assume his speed remains constant at the value shown by the horizontal portion of the graph. So if the velocity stays the same, at what point will he have covered the distance of 100 meters? So now we already have 55, right? We already have 55. So how much more does he need to travel? 100 minus 55. He has to cover 100. 55 he has already traveled. So how many more kilometers left? 45, right?
Yes, miss.
Yes, he has 45 kilometers left. How can we get 45? The breadth is going to stay the same because the velocity is the same. Velocity will stay the same. Okay, the question has mentioned his speed remains constant at the value shown, which is 5. So that means 5. But then what should we multiply to get 45? 5, how many times 5 do you get 45? So you divide 45 by 5. You get
9.
9.
9.
9. So if I want to add 9 further, further beyond 13, so what number will I end up? So 13 plus 9 is
13 plus 9.
22. So at 22 will I get 9 kilometers? I mean, sorry, 9 9 more seconds, let's say. Okay, so eventually at 22nd second, he will have traveled 100 meters. Did you understand this? No?
Yes, ma'am.
Yes,
Understood.
miss.
You understood? Good. So basically 55 he had already traveled. He needed to travel 45 more. We already have 5 meters per second velocity, but we needed to have 9 more seconds here. 9 more seconds here. So if we add 9 onto 13, we will end up at 22 seconds. So at 22nd second, he has traveled exactly 100 meters. Okay. Okay. Okay, now we are beyond our time. Do you want me to continue or should we stop here?
Let's stop.
Okay. Okay, let's stop. And I think you can do these questions on your own. If there is any confusion, please feel free to ask. Okay?
No, ma'am.
Okay, miss.
Okay, okay. And if anybody wants me to explain any question right now, you can ask right now.
No. Ma'am, tomorrow you will do chemistry class or physics class?
Okay.